Porosity, as indicated here by the symbol phi, is signified by a percentage and represents the volume of pore space divided by the total volume of the rock. Therefore, a rock with 12% porosity has 12% of its volume made up of void spaces. These pore spaces can be any size or shape. They can be relatively isolated or highly interconnected. Pore space in a rock depends on many factors. For example, porosity is dependent on how detrital grains in a rock are stacked together. As shown here in this generalized cubic stacking of spheres, grain stacking can be rather open, resulting in high porosity. Or stacking can be closer, as in this orthorhombic pattern, this tetragonal arrangement, or this rhombohedral pattern, and result in lower porosities. Although nothing has changed except the three-dimensional stacking of spherical grains, porosity has decreased from about 47% in the cubic pattern to about 25% in the rhombohedral arrangement. Of course, these figures assume that the spherical grains are solid. If they have intragranular porosity, as shown here, the total porosity would be greater and represent the combined intergranular and intragranular porosity. Other factors that alter porosity include variations in grain shape and the degree of sorting. In the case of sorting, the poorer the sorting, the lower the porosity, since smaller grains may fill in the pore spaces between larger grains. Porosity may be greatly affected by such secondary features as cementation, which can decrease primary porosity in a detrital rock, or by features that increase porosity, such as dissolution or fracturing.